Why aurora does not occur at the pole. Overview of latest understanding for effects of solar wind on planets. Cover diagram shows the mechanism by which aurora occurs. Aurora does not occur at the pole. Magnetism is a short-range force that exists only near moving charged particles. Therefore, while the distribution of charged particles in the diagram is correct, however, magnetic field as shown in the diagram does not exist at the poles. Protons of solar winds from the Sun collide with atoms and ions of the Earth. Charged particles running side by side magnetically couple with each other and distribute in a donut-like pattern. The proton distribution at both ends of the crescent cross-section becomes thin and is vertically contacts to the atmosphere of the Earth. There aurora occurs. Challenges of traditional model of Earth's atmospheric motions around the Earth. Why does Earth's atmosphere keep orbiting the planet? Trade winds cause the atmosphere to rotate clockwise relative to the Earth's ground. On the other hand, westerlies cause the atmosphere to rotate counterclockwise relative to the ground. Traditional theories explain that the cause of atmospheric movement on a global scale is the temperature difference caused by latitude, which is then bent by the Coriolis force of the Earth's rotation. However, the Coriolis force is a hypothetical force generated in the rotational coordinate system and does not move the atmosphere east-west relative to the ground. In this video we'll explain that the movement of the atmosphere as it orbits the Earth east-west is caused by the solar wind that collides with Earth's atmosphere. Earth's atmospheric movements due to solar wind. Atmospheric flows caused by Earth's rotation. Because the Earth rotates counterclockwise per day, the atmosphere that touches the surface also orbits. When the latitude angle theta is set, the orbital velocity changes with cosine cos theta, and as the latitude increases, the orbital velocity rapidly decreases. At the poles, there is no atmosphere orbiting the Earth. Trade winds driven by solar wind. The solar wind emits about 1 million ton per second, reaching about 300 to 900 kilometers per second when reaching Earth, with an average speed of about 450 kilometers per second. The Sun's rotation adds a rotational component of 1.89 km per second at the surface of the Sun's equator. Near the equator of the Earth, the solar wind collides perpendicular to the day hemisphere, so the components of the Sun's rotation drive the atmosphere clockwise, driving the trade wind. Solar wind driving the westerlies. The solar wind passing along the Earth's east side in the same direction of Earth's rotation causes magnetic bonding between charged particles. Kinetic energy of solar wind is transferred into the atmosphere. In the nighttime hemisphere, the Sun's rotational components and the counterclockwise rotation of the solar wind cause the Sun to accelerate counterclockwise. However, in the west of the Earth, the atmospheric flow caused by Earth's rotation is opposite to the solar wind, and the effect of the solar wind is weakened. As a whole, westerly winds blow in high latitude regions. Strong winds of typhoons were caused by solar wind. Mechanisms of typhoon. In the region's slightly northern latitudes above the equator, moist atmosphere touching the water surface rises with counterclockwise rotation due to Earth's rotation. As shown in Fig. 3, in the upper sky, the atmospheric flows rotate in a clockwise direction due to trade winds together with westerlies. The clockwise rotated winds flow toward the center. Therefore, on the right side of the typhoon's center, cold, dry downdrafts mix with warm, moist updrafts from the sea surface, and the water vapor from the updrafts condenses into rain, forming a low-pressure area of typhoon. Why strong winds blow and heavy rain fall on the right side of a typhoon? As shown in Fig. 3, on the right side of the typhoon, updrafts and downdrafts mix, causing water vapor to condense and become rain, lowering the central pressure and accelerating the convergence of swirling airflows, which leads to typhoon development. The conventional explanation on the typhoon airflow is caused by Coriolis force. However, the Coriolis force cannot cause the strong winds of typhoon. Route of typhoon. The route of a typhoon turns due to the flow of atmosphere of its route. That is, it develops in equatorial regions and moves toward mid-latitudes, shifting from regions with trade winds to regions with westerlies. In high-latitude regions, updrafts from the sea surface lose momentum, the rotational force in the upper atmosphere is lost, and the typhoon's strength weakens. Time changes on Earth's geomagnetism due to solar wind. Time change on geomagnetism at Guam Island region. Earth's geomagnetism has been described as if there is a bar magnet inside the Earth. However, there are slight regular change in Earth's geomagnetism that change noontime. As shown in Fig. 4, the horizontal component of Guam's geomagnetic field shows a change of about 50 nanotesla on a calm day. Mechanism of time change in geomagnetism. Sunlight ionizes the molecules in the atmosphere, increasing electrons and ions. However, since the mass of an electron is only 1,836 that of a proton, electrons do not affect the motion of protons. Electrons generated by the collision are neutralized. On the other hand, the solar wind collides head-on near the equator. When the protons in the solar wind move, they generate electric currents. As shown in Fig.5, it can be explained by the increase in geomagnetic field as solar wind protons are moved protons towards clockwise rotation by collision through Geer's mechanism. Magnetic coupling among running charged particles. 5.1 Magnetic coupling between moving charged particles. The magnetic action of the current I of a moving charged particle is described by the vector potential A defined in equation 1. B equals rotation A. The vector potential A is the energy per unit current as shown in equation 2. U equals minus IA. Because the energy between charged particles moving in parallel is low, magnetic bonds form between them. Acceleration of the solar wind by magnetic coupling of protons in corona area. The electric potential and vector potential is a short-range force that decreases with the square of the distance from the source. The magnetic effects of charged particles plays a crucial role in understanding the behavior of Sun's surface charged particles. As a fact, there is the jet-like plasma eruption called a spicule. That is, charged particles released by magnetic bonding from the Sun are pulled back by gravity. Once they reach the coronal region, charged particles run in parallel through magnetic bonding, resulting in extremely high speeds. Because the magnetic bonds of charged particles are chained, charged particles emitted from the Sun reach a heliopause, 120 astronomical units away from the Sun. Formation of the Van Allen belt by solar wind. Interaction between charged particles of solar wind and those in the high Earth's altitudes. The solar wind protons with the kinetic component of the Sun's counterclockwise rotation collides perpendicularly with charged particles in Earth's ionosphere that rotate counterclockwise near the equator, orbiting the Earth in the clockwise direction. On the other hand, in mid to high latitude regions, the charged particles orbiting clockwise in response to the westerly winds is accelerated by the solar wind and rotates widely far up to the tail. Formation of Van Allen belts. The charged particle band in Westerlies region is located at a higher altitude than the equatorial particle belt. In the region sandwiched between the upper layer in the clockwise direction and the lower layer in the counterclockwise direction, the electrons in the lower layer run parallel to the protons in the upper layer, allowing electrons and protons to combine and neutralize. Therefore, as shown in Fig.7, a proton belt with a crescent-shaped cross-section is formed by sandwiching a region without charge. Auroras occur at Earth's side edge of inner proton belt. The protons in the crescent-shaped cross-section of the inner Van Allen belt thins at the poles regions and touches perpendicular to the ground. Auroras glow in regions where the proton groups in the inner band, shown by white dots in Figure 7, touch the Earth's ground. The distribution of charged particles in Fig.7 is correct, but the magnetic field caused by point current is a short-range force, so the magnetic field is incorrect. Superrotation of Venus. Venus's superrotation is caused by the solar wind. As shown in Fig.8, there is an atmospheric flow called superrotation that orbits Venus's atmosphere at high speed. There is a paper that suggests this phenomenon is caused by latitude vertical circulation induced by heat. However, theories that do not consider the effects of the solar wind cannot explain the occurrence of the atmospheric flow. Kurosawa S. proposed the explanation that Venus's superrotation is driven by a mechanism same as Earth's trade winds. Structure of Venus's atmosphere. The Venus's atmosphere is both dense and hot, with a surface temperature of 460 degrees Celsius and a pressure of 90 atmospheres. The atmosphere above rotates clockwise at a fast speed, gradually slowed down as altitude becomes low. The mechanism by which Venus's rotation is reversed. Direction of rotation on Venus is opposite to Earth as shown in Fig.9. Change of Venus's rotation from counterclockwise to clockwise is considered as the result of the clockwise rotated atmospheric rotation at a pressure of 90 atmospheres. Jupiter's magnetosphere and Io's plasma torus. Jupiter's geomagnetism is caused by charged particles orbiting Jupiter's equatorial plane. Jupiter possesses a gaseous hydrogens on the outside and rotational period of Jupiter is 10 hours. The Jupiter's charged particles together with charged particles of the solar wind are responsible for Jupiter's strong geomagnetic field. The band of charged particles is chained by magnetic coupling and spread over a wide area, including the Galileo satellites. Mechanism of Jupiter's aurora. Jupiter's charged particle band has a donut-shaped cross-section on the equatorial plane, and when it leaves the equator, it forms a crescent cross-section as shown in Fig. 10. Auroras occur at the boundary where these charged particle bands meet at Jupiter. These auroras have brighter point regions corresponding to Galileo's moons. Solar wind accelerates charged particles emitted from Jupiter's moon Io toward ahead of the rotation. As shown in Fig. 11, the plasma emitted from Jupiter's moon Io flows out in a counterclockwise rotational direction. Why the plasma torus has a kinetic component in counterclockwise rotational direction. We can understand as plasma torus is driven by solar wind. Conclusion. The conventional understanding of the solar wind's effect on the Earth was that its effects were negligible because they were protected by the Earth's geomagnetic field. However, phenomena that cannot only be explained by the solar wind include trade winds, westerlies, typhoons, the Van Allen belt, auroras that do not occur at the poles, Venus's superrotation, and plasma torus of Jupiter's moon Io. The traditional theory that sets a planet's magnetic field resembling the gravitational field of long-range forces is far from reality. The reason the solar wind does not reach the ground is that the average free path of collisions between air on the ground is less than 1 micron. The author argues that solar wind protons collided with the primitive Earth's atmosphere, mainly composed of CO2, leading to the synthesis of organic molecules and the birth of life. 7. As for the effects of solar wind on Earth's weather, the papers was announced. 1. Subsequently, points needing revision were found in the drawings of the above papers. The author re-examined images and made some modifications to the selected images, and added explanations based on those images in this video. Thank you for your attention.